Welcome to Precalculus, section 4.5. We're going to attempt to do a couple examples here. This one is going to be number 54. It's from the book. It's not a homework problem, but it is, I think, a good example of teaching some of the basic concepts. This is one I would consider as somewhat tedious, but maybe it will teach the lesson well. I actually just recorded this full video and realized I made a significant error, so here I go again. First thing you want to do is take a couple of, it's kind of mark down the key characteristics, like the amplitude is 4. Also, in a problem like this, there is a vertical shift. So let's just say, let's just write up 4, kind of a little shorthand here. What else should we say? There's not a period change, so the period is still going to be 2 pi, and therefore the critical distance, put that down here I guess, the critical distance we've said is 2 pi over 4, and that means it's going to be just the regular pi over 2, which is kind of standard. And the reason is, again, because the coefficient in front of the x, the b, is that right? Yeah, the b is 1, so therefore the period stays a normal 2 pi, and critical distance a normal pi over 2. The last thing is phase shift. This is the most challenging part. This one you can probably tell, it's going to shift pi over 4. Since the period is normal, we don't have to do that much with it. However, I'm going to show you kind of the long way, just to get some practice with it. And that way is you set the thing in the parentheses equal to 0 and solve for x. That tells you where to start. I'm going to put that, I kind of say that, maybe I should put quotation marks around it because it's not really a start. Sorry for my horrible handwriting. So this should give us the details that we need to begin. One thing you might notice is since the amplitude is 4, it would go from -4 to 4 would be the range, but it's shifted up 4. So instead of being -4 to 4, maybe I should write this down. Instead of going -4 to 4, since you add 4, it's going to go from 0 to 8. So our graph will mainly be in the, will always be above or at or above the x-axis. So let's make our scale. Unfortunately, we're shifting pi over 4 to the left. Let's make that negative pi over 4. And our critical distance is pi over 2. So, we are going to, we can just keep stepping these off here. If you add a half a pi to a negative quarter pi, you get a positive quarter pi, and we're going to jump by pi over 2, which is the same thing as 2 pi over 4 if you want to have a common denominator. So the next jump would be here at 3 pi over 4. Hopefully these all fit. Then it will be 5 pi over 4. Then it will be 7 pi over 4. That should get me my first period. I need to do another one. 9 pi over 4. 11 pi over 4. 13 pi over 4. 15 pi over 4. Are we done? I think so. We should have 9 values to go from your, let's see, let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9. That takes you from, for cosine it'll go maximum, intercept, minimum, intercept, maximum, intercept, minimum, intercept, maximum. So that's going to do it. Switch back here. Okay, I think we are ready to graph. As unpleasant as those were, we did it. Let's mix it up a little bit with colors. And I'm going to make our dots here. Oh, you know what we got to do first is make our Y scale. So we're going to go up to, whoa, a little bit big there. We're going to go up to, alright, I'm getting to fancy with this thing here. We're going to go up to 8, and our equilibrium point will be 4. So now watch these things here. Okay, so they'll start a dot at negative pi over 4, 8, there, and then pi over 4, and then minimum, equilibrium, maximum, equilibrium, minimum, equilibrium, maximum. So once you get your x and y scale done, it's simple. Let's connect the dots. Here we go. And you might be able to do better than I can drawing this, but there it is. I think that is correct. Double check with what I have. Looks good. So hope this was helpful for you, and see you on. I'm going to do another problem, so I hope you watch that one too. Thanks.
Made with Doodlecast Pro.